So in this video, we're going to start the process of implementing a queue in C. A queue is relatively similar to a stack in the sense that we're still using this same node object to establish links between different items inside of our data structure. However, the main difference being that a stack was a last in, first out data structure, where the last thing added was the first thing removed, whereas a queue is a first in, first out data structure, meaning that the first thing that was added will be the first thing that's removed. And this mostly mimics the idea of like an actual queue or lineup. You know, if you line up at the store, the first person who's in the line gets serviced first, and then the next person, and so on and so forth like this. So the main idea of a queue is to emulate that idea of lining up for something. So it's used in a lot of applications like simulating lineups in stores or even managing processes on your computer, which have a natural sort of first in, first out queue type structure a lot of the time. So let's start off by implementing our header, which will require a few different includes, and all of these includes are really the same as our stack. We include our node, our standard def, we include stdio, and we include the standard lib. And then the structure for our queue is going to be pretty straightforward as well. We're going to have a node that represents the front of the queue. I'm going to create a node that represents the rear of the queue, and I'm going to create a size for the queue itself. And I'll discuss each of these attributes in a little bit of detail, but first let's just discuss what kind of operations we have. We have an initialization operation. We have the ability to do an onqueue, which adds something to the queue. That requires us to provide the queue as well as the value that we're trying to add onto the queue. So we have that type of idea. We have a dequeue, which allows us to remove a value from the queue. And then like our stack, we also have a peek. And the peek allows us to see what's at the top of the queue, but doesn't actually remove anything from the queue itself. So to study these different operations, let me show you a little example of this. So when we're taking a look at the idea of queues, what we have is this process where, let me just change the color of this pen here so it's easier to see, where we have, some different items inside of our queue. So in this example, maybe we have the values 1, and maybe we have the value 2, and we'll just put in 3 values. So maybe we have the value 3 as well. This right here is the front of the queue, and this right here is the rear of the queue. If I were to add something new to this queue, what I would do is I would append it to the end, since I want it to be the last thing that's removed, so it's the newest thing at the end of the list itself. So that means this rear gets updated to point to the new thing that was inserted. So that would be the idea of the insert. For the dequeue, we're actually going to remove what's currently at the front, and then just move the front down 1 like this. So that's the idea of how the removal works. So do you see that we remove from the front and then we insert to the rear? That's the main idea of what we have with a queue. So let's start our process of actually implementing this idea of a queue. I'll come over to our queue.c. And inside of this file, we're of course going to include our queue.h. And we're going to start off with our initialization, which is really the same sort of initialization that we would see inside of a stack, right? We just initialize everything to null or 0. So null for the front and rear pointers, and then 0 for the size of the queue. And then we're going to go ahead and return that queue back. So that's the idea of it. Now, for this video, we'll just go ahead and do our onqueue. So that'll be the first thing that we'll implement here. And the onqueue is not too complicated of a process. So we take in the queue that we want to insert values for. We take in the value that we want to insert. And then we're going to create a new node. And that node is going to be the one that stores the data that we want to insert. So we're going to malloc it for the size of our node struct. And then we're going to set the value of the node to be equal to the value that we're trying to insert. And when you think about the idea of the onqueue, it's being added to the end of the list, which means that it won't point to anything, which means that its next is null. That's just because there's nothing that follows it, so there's nothing for it to point to. That's why that's set to null. Now, in terms of the two situations that we have two cases here. The size could be 0, which means that there's nothing in the queue. In this case, what we're going to do is we're going to say the front of the queue is equal to the node that we're inserting, but also the rear of the queue is equal to the node that we're inserting. And then the queue size increases by 1. And really, to understand that, just like consider the fact that, like, so if we have one value inside of the queue, it's both the front and it's the rear. It's the front and back of the queue, right? Now, if we insert something with a value already in the queue, what happens is that value gets added to the end, right? And then what's going to happen is this rear is going to move to point to this. And the front is, of course, still pointing to the first value that was inserted. So that's how this general idea is working. It's setting up this front and rear pointer. And I'll show you this when we come over here and we say, okay, so then from here, otherwise on this else statement here, we're going to have the queue rear next is equal to the new node. And then the rear is going to point to that node that we just inserted, right? And then the size increases by 1. And that's really imitating this idea, right? So we are basically adding something to the rear moves to the thing that we added, and the size of the queue increases by 1. So that's our onQueue operation. Now let's give this a little test just to make sure that everything is working as expected. So we are going to include our queue.h. We are going to go ahead and include our standard IO. And I'm going to create my main function. And inside of this main function, we're going to have a struct queue that we're going to use the init function to create. And then I'm going to onQueue a few values. So I'm going to add on the value 1, and I'm going to add on the value 2. Just like this. And then what I'm going to do to test this is I'm going to go ahead and print out the value of the front of the queue. And I'm going to print out the value of what follows the front of the queue. Just like this. So that will allow us to see if this is actually working. That will just return 0 to end off this function. Okay, so let's go ahead and compile this. Our GCC will take in all the different pieces, node, queue, and main. And generally we should see, okay, in this case we do get one error. I think I just forgot a semicolon after the struct declaration. So that's okay, there we go. And when I run this, do you see that I get 1 and 2 as an output? So just to quickly review, what's happening here is when we initialize, we have nothing. The first insert is going to place 1 on the queue, and this is both the front and the rear. After the second insert, we have 1, which is the front of the queue, points to 2, which is the rear of the queue. So when we get front.value, it's this one here, which is the value 1. So this gives us the value 1, as we see here in the output. And then this one here is the next, which gives us a value of 2. And that's why we see 2 in the output afterwards. So this gives you a hopefully straightforward explanation of how the queue operation is going to be set up inside of C. So this gives us a nice onQueue operation. So in the next video, what we'll do is we'll take a look at dequeue and peek to see how we can implement those two operations. So thanks so much for watching, and I'll see you in the next video.